Namaste. I, Nitika Chatwal, Assistant Professor in Jyoti Vidyapeeth, Women's University, is here to deliver the lecture on drug stability, which is in physical pharmaceutics, and it is in the unit 5th. So, here we doing the continuation of previous lecture, drug stability, right? Earlier, we discussed the drug stability factors. Now, in physical degradation, we start absorption of water. Hygroscopic drugs absorb the water from external atmosphere, causing the physical degradation. What are the hygroscopic substances? These are the substances that absorb moisture from where atmospheric or environment, right? Effervescent powders and tablets will deteriorate if stored in a moist temperature. Effervescent tablets are what? If they removes water and make harsh substances that deteriorate fastly. And if tablet is effervescent, that the moisture will be evaporated and that will produce a deteriorate product, right? For example, powders in which liquefaction and degradation may occur as a result of absorption of water. Now, suppositories which base made from hydrophilic substances, and hydrophilic are what? Which are what? Lipid loving, right? Hydrophilic. Lipid loving or not? No. Hydrophilics are what? Which are water loving agents or substances that are what? Glycerine. Glycerine is the main example of a hydrophilic agent. Glycerine, gelatin, and polyethylene glycols are what? Hydrophilic substances, which comes under what? Hydrophilic substances. The consistency of these forms becomes jelly-like appearance, right? Now, how we prevent this absorption of water or physical degradation? The product should be placed in well-closed containers. While doing storage conditions or storage stability, then we can prevent the absorption of water, right? And to place the product in dry place where there is no moisture category or environmental phase, right? Okay. Now, we comes to another point, that is crystal growth. How crystal growth can deteriorate or degrade a product. Drug, when loose water, becomes saturated and crystal growth occurs. If drug loses water, then the saturation occurs, and that will allow the crystal growth, right? Now, crystallization is enhanced in porous tablet. Those tablets who have pores in it, right? That are not compactly formed or that have pores in it. In solutions, after supersaturation, crystal growth occurs. For example, injections of calcium gluconate in this suspension crystal settle down and caking occurs, and suspension becomes unstable. That will form a deteriorated calcium gluconate injection that will not be able to gain its shelf life, or its shelf life will be reduced. And in ophthalmic preparation, many suspensions are available, and in those suspension, crystal settles down and crystal growth occurs, and that will form caking. After that, those suspensions of ophthalmic are becomes unstable and of no use, right? Now, what will be the prevention? How we prevent it? The crystal growth. Solution stabilizers are added. As we know, stabilizers are what? Which stables down the preparations, right? Now, in suspension, incorporating of surface active agents means surfactants. And I also give many times the examples of surface active agent, which is SLS, sodium lauryl sulfate, that is water loving surfactant and is readily available in any chemical lab, right? So By incorporating this surface active agent, and other examples are also available, by incorporating it, we can prevent the crystal growth, right? And the second mean is by increasing viscosity of suspending material. If we enhance viscosity of a suspending material by means of enhancing it, we can prevent the settling down of crystals or suspension, and caking does not occur and suspension doesn't become unstable. It will be stable in nature. Now, the other form is polymorphism. Now, polymorphs show significant difference in important physicochemical properties such as solubility, dissolution rate, and melting point. In polymorphic changes, crystal forms are changed. This may cause change in solubility and possibly crystalline growth in aqueous suspension. For example, cortisone acetate suspension, right? Now, how we prevent polymorphism? By suspending agent like methyl cellulose and ethyl cellulose are added, and these suspending agent does not does not or prevent the formation of polymorphs. If polymorph not occur, then the polymorphism process does not occur, and after this, the degradation of the product is controlled or prohibited or prevented. Right now, photolysis. What is photolysis? When molecules are exposed to electromagnetic radiation, they absorb light. And what are the light? Photons at characteristic wavelength, which cause increase in energy, which can cause decomposition, right? For example, sodium nitroprusside in aqueous solution, which is administered by IV. IV means what? Intravenous infusion for management of acute hypertension, right? Okay. Now, how we prevent it? Use of amber colored bottles is very necessary in preventing photolysis, because amber colored bottles are there, which does not allow light molecule or photons to come over, and degradation of the molecule is prevented, right? So photon or light molecules are not absorbed, they are passed by the amber colored bottles, right? Now, storing the product in dark packaging in cartons also act as physical barriers to light, right? Now, the other means is color changes. Color changes indicate chemical or photochemical decomposition of the active ingredient. If the active molecule or the suspension or solution or any drug compound or any drug preparation changes color, then we know this decomposition occurs. Now, dyes or other ingredients color changes are of two types, and by what means the two type color changes are occur? Loss of color or development of color. By these two means the color changes occur. If a molecule or drug product loses its color, then we suggest the molecule is decomposed. And if there is no color and suddenly there is a development of any color is present, then we know, oh, the decomposition occurs, right? And the product is degraded. For example, phenolphthalein color changes as the pH changes, right? It is colorless in acidic solution and pink in basic pH, right? Ascorbic acid tablet turns yellowish brown after decomposition. Now, how we can prevent it? Protect the product. Protect the product from light and air. By protecting the product from light and air, the color changes can be prevented, and by avoiding the using reduction substances as additives, the color changes will be altered, right? Now, what are the chemical degradation steps? Hydrolysis, isomerization, racemization, epimerization, decarboxylation, elimination, and oxidation. These are the chemical degradation steps. In hydrolysis, ester amide by barbiturates, um, amides, carbon nitrogen bond cleavage. For example, in ester, the examples include aspirin, atropine, physostigmine, and procaine have involved acyl or acid cleavage, right? So after this, we in this chemical reaction occurs, and after these chemical reaction, the degradation occurs, right? And now in amides, amide bonds are less susceptible to hydrolysis than ester bonds. Ester bonds are more susceptible. So the leaving group and amine is a poorer leaving group. It involves cleavage of amide linkage to give an amine instead of alcohol, as in case of esters. For example, chloramphenicol, chloramphenicol and barbiturates, right? So amides are less susceptible to hydrolysis, right? In barbiturates and amides, barbiturates and amides contain functional group related to amides but have a tendency to be more reactive. Barbituric acid such as barbital, phenobarbital and amobarbital undergo ring opening hydrolysis where ring opens and this chemical reaction leads to their degradation, right? There is CN bond cleavage also in benzodiazepines such as diazepam, oxazepam, and nitrazepam undergo ring opening due to reversible hydrolysis of the amide and azomethane bonds, right? In benzodiazepine oxazole such as oxazolum, flutazolum, halozolum, and floxazolum. These are all drugs are undergoing opening due to hydrolysis, which leads to their hydrolysis and that leads to degradation. Now, how can we prevent all types of these degradation, chemical degradation? Now, prevention make packaging in suitable moisture resistant packs while preventing by suitable packaging uh, such as strip packs and storage in controlled humidity and temperature. Where RH and temperature are maintained, then there will be prevention of hydrolysis. Hydrolysis of certain drugs such as benzocaine and procaine can be decreased by the addition of specific complexic agent like caffeine to the drug solution. They are there to prevent the hydrolysis of certain drugs, right? Now, what is now comes isomerization. What is isomerization? Isomerization is the process by which one molecule is transformed into another molecule, which has exactly the same atoms, but the atoms are rearranged. Means the atoms shift their position, right? Okay, but the molecule is as same as first one, right? Now, what is racemization? Racemization refers to partial conversion of one enantiomer into another. It involves the optically active form of a drug into its enantiomer, right? And in racemization, the degradation occurs and the smell causes is very bad. Okay, after smelling the product, we say, oh, it goes to racemization, right? Now, epimerization. What is epimerization? It occurs with the compound having more than one asymmetric carbon atom in the molecule. At equilibrium, both apimers are present but not in equal proportion. For example, Under prolonged storage, solution containing ergometrin is decomposed by hydrolysis and isomerized to ergometrinin, right? So decarboxylation now. What is decarboxylation? Elimination of CO2 means carbon dioxide from compound drug substance having a carboxylic acid group is sometimes susceptible to decarboxylation. For example, 4-amino salicylic acid and procaine, right? Now, how we eliminate these type of chemical degradation? In elimination reaction, some groups of the substance is eliminated. For example, triaminolamine eliminates its hydroxymethyl group and forms formaldehyde, right? Oxidation reaction also occurs, which degrade the molecule. Removal of an electrolyte, electropositive atom, radial or electron, or the addition of an electronegative atom or radical oxidation is controlled by environment. For example, light, trace elements, oxygen and oxidized agents, right? What are the type of antioxidants, right? Uh, for example, in auto-oxidation, the examples are oil, fat, and unsaturated compounds in which auto-oxidation occurs. They oxidize normally without any reaction. They oxidize normally. Oxidation in which the oxygen present in the air is involved. This process proceeds slowly under the influence of atmospheric oxygen and molecules or products which goes atmospheric oxidation are known as auto-oxidation, which are oil, fat, and unsaturated compounds, and the products which goes under photo-oxidation in which removal of the electron is involved without presence of oxygen is adrenaline, riboflavin, and ascorbic acid. These agents are photo-oxidized. Now, how can we prevent oxidation? By adding chelating agent in the product or the formulation. And what is the chelating agent? The example of chelating agent is EDTA, right? This is the main and previously known example of chelating agent, right? And what are the antioxidants which can be used in the preparation are citric acid, tartaric acid, ascorbic acid, isoascorbic acid, potassium or sodium salt of metabisulfides. Okay. Now, microbial degradation can also occur. Microbial degradation means there is the presence of a microbe. Now, contamination of a product may sometimes cause a lot of damage and sometimes may not be anything at all. Thus, it is dependent on the type of microbe and its level of toxicity it may produce. If parenteral or ophthalmic formulations are contaminated, it may cause serious harm because parenteral or ophthalmic products directly get in contact with our blood or the mm, eyes, right? In parenteral, the drug directly goes through the intravenous system, so the harm could be very severe, right? So we have to block the microbial degradation of parenteral products and ophthalmic products in major size. Okay. Now, thank you so much. That's it for this discussion. Let me know if you get it or not. Please comment below. And if you have any queries, please ask me. Okay. And please prepare some notes and important question. Write down the important question as I discussed in this discussion. Right. Okay. Thank you. Thank you so much.